Some basic manipulation of powers is going to be helpful for this course. So let's work through a few problems together. The first problem is a division problem where we divide 10 to the negative 4 over 10 to the second. And so the way this works is, since it's a division, you would take 10 to the negative 4 minus 2, because it's a division, and this equals 10 to the negative 6. If you were to multiply these two numbers instead, you would take 10 to the negative 4 times 10 to the 2, and here you would add them. So this is 10 to the negative 4 plus 2, and this is 10 to the negative 2. If we were to raise the power, if we were to raise the number 10 to the negative 4 to the power of 2, then we would multiply. So we would have 10 to the negative 4 times 2 is 10 to the negative 8. And then, of course, a standard to remember is that 10 to the power of 0 is equal to 1. So let's say we wanted to make elastic gels with a thickener, gellan, and if you use 2.5 grams of gellan in 200 grams of water, and you wanted to know what the percentage of this is, you would take 2.5 grams over 200 grams is equal to 0.0125, and since percent is 1/100th of this, we would move the decimal point over by 2, and this would then be 1.3%. In another example, let's say Dave Arnold wants to make a gel of cranberry juice made with a thickener agar-agar. So if the gel has a concentration of 1.5% of agar, what would be the total amount that you would have to add in order to make a gel from 300 grams of cranberry juice? So 1.5% is equal to 0.015, and we know that whatever amount we put in over 300 grams is going to equal this percentage. So we've put this equal to 0.015. And then we solve for the amount we don't know. And so this then equals 300 grams times 0.015 equals 4.5 grams. So that's how much agar-agar you would have to add to make this gel. It's often helpful to have a strategy for how to approach problems. So here I'm just going to take a problem that you probably don't know anything about yet, and we're just going to try to solve it based on a few things. So the problem goes that we know the specific heat of butter. It's 1.26 joules per gram Kelvin. And we know the mass of butter. It's we've converted to milligrams here, so it's 45,000 milligrams. And then we're told that we add heat, and we do this in the amount of 2.8 kilojoules. So now the question is, by how many degrees does the butter heat up? So what is the difference in temperature? And so I'm just going to give you the equation that we would use for this, and you may know nothing about this equation, but you should be given everything in the problem still to solve this problem. So the equation is that Q, which is the heat, is equal to the mass times the specific heat times delta T. So the first thing I recommend doing when solving this problem is to write out everything we know. So we write out the specific heat equals 1.26 joules per grams Kelvin. The mass is in milligrams. That's a very inconvenient unit. So 45,000 milligrams equals, and then we do a dimensional analysis on this. We know that 1 milligram equals 10 to the negative 3 grams. And this equals to 45 grams. So we have 45 grams of butter. The heat, which is our Q, is 2.8 kilojoules. We know that 1 kilojoule is equal to 10 to the 3 joules. And so the number of joules we have then is 2,800 joules. So now we can just plug this into the equation. And first, though, we need to solve for delta T. So let's solve for delta T, and delta T is equal to the heat Q over the mass times the specific heat. And if we plug in the numbers into this, we have that delta T equals 2,800 joules over 45 grams times 1.26 joules per gram Kelvin. And this is equal to 49. And if we do dimensional analysis, we cross out the joules, we're left with, we cross out the grams, we're left with 1 over Kelvin, and that's the same as Kelvin. So the temperature difference would be 49 Kelvin. So you just solved a problem, basically without knowing much about the problem at all, but you've done it by having a very good strategy, by knowing the equation, and by keeping your units straight, and by using dimensional analysis. And this is how I recommend you approach all problems as you go along. It's also going to be helpful to remember some basic geometry for this course. One of those things is just knowing the area of a circle. The area of a circle is equal to pi r squared. Another thing that will be helpful is knowing the volume of a sphere. And often in this class, we make simplifications by saying that foods are really more like spheres. So for example, later on in the course, when we cook a turkey, we just imagine that the turkey is actually a sphere, and that makes our calculations a lot easier. So the volume of a sphere is 4/3 times pi r cubed. Another thing that comes up often is the area of a cube, where all the lengths are the same, and this is just the side of the cube cubed. So you would take all the sides of the cube times each other, and we would do the same thing for a prism. So for example, a steak would very easily be simplified to be a prism, where we would take the area times the height, and that would give us the volume of the steak. Next, we're going to remind ourselves of logarithms and exponentials, and both of these are basically the scientist's way of dealing with a lot of big numbers or small numbers or a lot of zeros. So logarithms is another way to say the order of magnitude of something. So the logarithm of 100 is 2, so we just count the zeros. The logarithm of 10 is 1. The logarithm of 1 is 0 because there are no zeros. The logarithm of 1 over 10 is -1. The logarithm of 10 to the 5th is 5. And so basically the logarithm of 10 to the x is x. And similarly, 10 to the power of the logarithm of x is x. And the natural logarithm is the corresponding way to deal with exponentials. So the natural logarithm of e is 1. The natural logarithm of e to the 5th is 5. Another thing we would often ask you about in this class is to take some measurements and then plot them on a graph to see if there is some relationship between two different variables. So now I'm going to quickly summarize how you would go about this. So let's say you measure the pH of curdled milk. And curdled milk is basically what you would use to make cheese. And so you add vinegar, which is acidic, at different volumes, and you then take the measurement of the pH. And so here is the measurements we would have. We would have at 5 milliliters, we would have a pH of 7.1, 10 milliliters, 6.5, and so on in this list. So first we would decide what the dependent variable is, and here clearly pH depends on how much vinegar we would have added. So based on this then, pH would be on the y-axis, and the volume of vinegar would be on the x-axis. And then we would just add our data points based on this. And as you can see, there is a linear relationship between them. So if we wanted to draw a best fit line, we would want to do it so that it fits the data points as closely as possible. And so we've done that here. So if we next wanted to calculate the slope of the line, we would do this by taking two different points on the y-axis and two different points along the x-axis. And so now the slope of this is going to be the differences between these divided. So 8 minus 4 over 0 minus 28. This then equals to minus 0.14. And there's a negative sign there because the slope is sloping down and not up. So now if we wanted to write an equation that tells us what is the pH depending on how much vinegar we add to milk, we could do that. And so the equation would be pH equals the slope, which is minus 0.14, times the volume of vinegar. So then we would have to add where this slope intercepts with the y-axis, and we can read that off this graph. And it turns out that this is 8. So this is our equation for what the pH is depending on how much vinegar we add to milk.